Welcome to section 0.1, Sets Review. Today's objectives are to use set notation, interpret and make Venn diagrams, identify unions, intersections, and complements of a set. So our definitions: a set is just a collection of objects. With math, we have our sets of numbers, like we have the natural numbers, the whole numbers, integers, rational numbers. Those are all types of sets. In your house, you'd have the set of dishes, your set of silverware. So that is just a collection of objects. An element is each object in a set. So if you're looking at the rational numbers, 3/4 is an element of the rational numbers. It belongs to the rationals. Set notation. We name sets using capital letters, and its elements are written within curly braces. The braces that look like they're shown on the screen. So whenever we write a set, we always place the elements inside the braces. We'll see some examples as we go forward. The Greek letter epsilon is used to denote when something is an element of a set. It's a stylized looking E. So here's an example at the bottom. Let C be the chapters in your book. That'd be your textbook. Then the chapters, C equals, in the braces, 0, 1, 2, 3. And you'll notice we have the commas there between our numbers. Once we establish a pattern, usually it takes 3, maybe 4 elements. We can use a dot, 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 which is an ellipse, to show what's missing. And then we are only going through chapter 12, so our last number has to be shown if the set ends. This one goes to chapter 12, so we would have in braces 0, 1, 2, 3, dot, 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 12. This shows us that chapters 0 through 12 are in this book. So we use that ellipse to shorten out writing everything, or if we said all the numbers greater than something, we could type the first numbers and then use the ellipse at the end. To show negation of something, we use that backslash just like we do for not equal. If we use the backslash through the stylized E for element, it means it's not an element. So if you look at our C is the chapters again, we have 4 is an element of C, but 15 is not an element of C. We use this backslash as negation symbol for all sorts of different things in math when it's a not. So you'll see that used extensively. So we use Venn diagrams in sets. Venn diagrams are helped to depict what a set is and how it's related to other sets. A set is represented in a rectangle. The rectangle is what we call the universal set, and it's denoted with the letter U. The U is not always written. Sometimes you'll just see the box with the circles inside. You will not have the actual U written in there. It's understood, if we have a rectangle with circles in it, that we are talking about a Venn diagram, and anything not in the circles is part of the universal set. Like it says here, sets and subsets of universal sets are generally shown in circles or ovals, but there's no rule that says they have to be. We can make them with squares, triangles, whatever we want to. You'll notice, hopefully, that the set are labeled, and they're labeled right by where the circle is. So this is set A right here, and that's for this left circle, and this is set B is for the right circle. And you'll notice that the two circles overlap in the middle. That's what they have in common. So the 7 and 8 are both parts of set A, and they're part of set B. Then you'll see our numbers down here on the bottom. That means they are neither in A or B, and they're just part of the universal set. And this set is the natural numbers from 1 through 11. So it says here, given the Venn diagram below, answer the following. We want set A. Well, set A is going to be everything inside the circle. So we have our set. We have 2, 4, 6, 7, and 8. You'll notice I'm using the curly braces. Set B is 7, 8, 9, 10, and 11. And the universal set is all the numbers in the rectangle. And I'm going to do 1, 2, 3, and it goes dot, 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 because everything's included. Notice I still use the commas through 11. and we close our curly braces. There's set A, there's set B, there's a universal set. So we have some more definitions. When we're talking about sets, we have unions of sets and intersections of sets. A union is when we combine two or more sets. We're basically combining them into one set, and we denote it with looks like a capital U. It's a little bit different. It's a symbol. It's a U symbol for this. That means union. So we mash them all together. What do both sets in total have? And then the intersection is what they have in common. And this intersection is denoted with a upside down U, almost like a staple. All right, so A union B, A combined with B, is all the numbers. We only state each number once. So 2, 4, and we have gaps here, so we can't use an ellipse. 6, 7, 8, 9, 10, and 11. That is the combined 2, 4, 6, 7, 8, 9, 10, 11. Notice again, I'm in curly braces. That second curly brace is looking pretty shabby. We will fix it. It doesn't look much better. The A intersect B is what do A and B have in common? What's in the common area between the two circles? And it is just 7 and 8. That is our intersection. Again, using curly braces. Hopefully your curly braces look a little better. The stylus is a little bit tricky today. All right, some more definitions. A subset. If every element of one set is included in another set, it is called a subset, and it's denoted with the sideways U. And it would be read like, for what below is that C is a subset of A, is how this is written. All right, so if you're looking about silverware, a subset of your silverware would be your knives, another subset would be your spoons, another subset would be your forks. When we talk about numbers, the natural numbers are a subset of the real numbers. They're also a subset of the rational numbers. A complement is what elements are in the universal set but not in the set named. So we denote this with an apostrophe. So if you have B, the set B with an apostrophe, that is B complement is how we read this. B complement is whatever is not in B. And if you look at your set, B includes everything in here. So everything that's not in there is a complement of B. So we're looking at the numbers 1 through 6. 1, 2, 3, 4, 5, and 6 are not inside B. Here on the bottom, we have that C is a subset of A because everything in C, the number 7 and 8, are also included in A. A is containing the numbers 2, 4, 6, 7, 8. B is not a subset of A because 9, 10, and 11 are part of B, but they are not part of A. So B is not a subset of A. We will use some of this notation, especially from the last slide. The union and intersection are used quite a bit when we do a thing called interval notation, which we will take up later this chapter. All right, we got some more definitions going. We have the empty set. Sometimes it's called the null set. If there are no elements in a set, it is called an empty set or null set. Empty sets are denoted one of two ways. We use empty curly braces, or we use a circle with a slash through it. Either one works. Only use one, don't use both. So in this case, you'll see that D is a circle above the sets A, B, and C. Sitting all by itself, there's no numbers in it, so it's empty. So D is either the curly braces that are empty, or D equals the symbol, the circle with the slash, saying that there is nothing inside. That is all for section 0.1. We were looking at sets today. Looked at a lot of definitions. Looked at set notation, universal set, the union and intersection of sets. We looked at subsets and a lot of the notation. Thank you for watching and have a nice day.